This is Professor Peld, and this is Algebra 2, Chapter 7, Section 2 on graphing rational functions. So next thing is the vertical asymptotes. So essentially, when you simplify the rational functions slash equations, the denominator could not be 0. Okay, so one of two things will happen if the when you find the domain gaps. Either it'll be a vertical asymptote, or B, an asymptote or hole. Sorry. Okay, so one of four things will happen with the vertical asymptote. If you have one, it'll approach from the right and go up to infinity, approach from the left and go up to infinity, approach from the right and go down to negative infinity, approach from the left and go from negative infinity. Because you can approach from two directions and go two directions as far as the function value goes. Either way, you get a vertical line that's invisible on the graph. Let's say singular x equals a value type functions. So if you have a common factor in the numerator and the denominator that cancels, it makes a hole in the domain, which is actually a hole in the graph. So that only happens when you have a common factor. Okay, so again, if the numerator and denominator, when factored, have a common factor that cancels, that's what makes a hole. Otherwise, it's an asymptote for the domain restrictions. So let's go through the problems here and find out what happens. Okay, in the first case, numerator and the denominator have nothing in common to factor out, but x squared minus 9 cannot be 0. So if I add 9, x squared cannot be 9. And if I square root that, x cannot be plus or minus 3. So as far as vertical asymptotes and holes, there are no holes because the numerator and denominator had no common factors that canceled. And the vertical asymptotes are x equals 3 and x equals negative 3. Okay. All right, let's take a look at the graph to verify that is actually true. So our numerator is x divided by denominator, which is x squared minus 9. And what you'll see is we have two vertical asymptotes, and they're invisible lines that they can't cross. A little curvy there. Trying to freehand it. So that's x equals negative 3. And right here, again, not very straight, but you get the idea, is x equals 3. No holes. Okay, next problem. This does have something common in top and bottom, because if you remember, this is x plus 3 over 1x squared plus 0x minus 9. So if I factor that out, I get x squared cubed, x plus 3, and x plus 3 and x minus 3. Let me fix it up a little bit. Okay, because remember, 1 times negative 9 is negative 9. Factors of negative 9 and 3 are negative 3, which added up gives us 0. So when that cancels, I get 1 over x minus 3 is my new f of x function that's been simplified. Okay, so as far as vertical asymptotes and holes, okay, x minus 3 cannot be 0, so x cannot be 3. That is our vertical asymptote. However, the factor that canceled is a hole, because that's also a domain gap. And that gap in this case is a hole at x equals negative 3. So it's negative 3 comma something. So the question is, how do you get the other part, the y value, in the coordinate of the hole? Well, plug it into the new equation. You get 1 over negative 3 minus 3, right? Because I'm using, again, the final function. I get 1 over negative 6. Okay, so let's look at that on a graphing calculator. So this time we can just change this to an x plus 3 on the top. And we notice that we only get one invisible line vertical asymptote right here. At x equals 3. So we said at negative 316 there was a hole. We don't seem to see one here in the calculator. That's because it's infinitely small, right? Every point is infinitely small. You cannot, there's points don't have a size. You can't see them, okay? However, if you check the table of values, menu, table, split screen, and you go to negative 3, you can clearly see it's undefined. There's actually a hole there, okay? Any value before or after, like 3.1, I'm sorry, negative 3.1, negative 2.9999, all of that, those exist, but that one, exact one does not. Okay, last one of the examples, x plus 3 and x squared plus 9. They have no common factors because x squared plus 9 does not factor. Also, x squared plus 9 cannot equal 0, so x squared cannot equal negative 9. So if I square root both of those, I get x cannot equal plus or minus 3i because it's a negative 9, right? So it's imaginary. So there is no domain restrictions. So as far as vertical asymptotes and holes go, there are none of either in this case. Okay, and we'll check the graph to verify that it's actually true. So we'll go to our calculator, and let's see. We'll change this to a plus 9, and we can see it's just a little bumpy line there. No asymptotes, no holes. Okay, pause the video. Try these student problems for yourself. Okay, first problem, the numerator and denominator have no common factors. X squared minus 1 cannot be 0. So if I add 1, x squared cannot equal 1. So if I square root that, I get x cannot equal plus or minus 1. So as far as vertical asymptotes and holes, there was no common factor restriction, so there were no holes. But x equals 1 and x equals negative 1 are vertical asymptotes. Okay, in the next problem, we have x minus 1 over x squared, 1x squared, plus 0x minus 1, which factored is really x minus 1 over 1x minus 1 and 1x plus 1, because 1 times negative 1 is negative 1, and the factors that are negative 1 and 1. So that cancels here, leaving me with 1 over x plus 1 is my new function, one simplified, which means since something cancel, I both have a vertical asymptote and a hole here. Vertical asymptote and hole. Okay, so x plus 1 cannot be 0, so therefore x cannot be negative 1. So that is our vertical asymptote. And since x minus 1 canceled, x cannot equal 1 is the x value of the hole. To get the y value, you just need to plug it in. So I get 1 over 1 plus 1, or simply 1/2. When I plug it into the function, gives us the location of the hole. In the last problem, x squared plus 1 cannot equal 0. X squared cannot equal negative 1. And if I square root that, x cannot equal plus or minus I, or 1i, whichever one you want to put. Since it's only imaginary restrictions, vertical asymptotes and holes, they're none of each, or either. Okay, that is the end of part 2.